Hey everyone, welcome back to my channel. Have you ever looked up at the sky and wondered what's really up there? Today we're diving into the invisible blanket that surrounds our planet, the atmosphere. Introduction. The Earth's atmosphere is a complex, dynamic system of gases that surrounds our planet and makes life possible. It regulates temperature, facilitates weather, and protects living organisms from harmful solar radiation and space debris. Despite being largely invisible, this thin layer plays a crucial role in supporting ecosystems, enabling communication systems, and maintaining the planet's energy balance. In this video, we'll explore the structure, composition, functions, and human impacts on the atmosphere in detail. Composition of the atmosphere. The atmosphere is primarily composed of nitrogen N2, which makes up about 78% of its volume, followed by oxygen O2 at 21%. The remaining 1% consists of argon, carbon dioxide, neon, helium, methane, krypton, hydrogen, and water vapor. Although water vapor and carbon dioxide are present in trace amounts, they are crucial for processes like the greenhouse effect and the water cycle. The exact composition of the atmosphere can vary depending on altitude, geographic location, and human activity, especially in urban or industrial areas. Layers of the atmosphere. The atmosphere is divided into 5 distinct layers based on temperature gradients and other physical properties. Let's see one by one. 1. Troposphere. This is the lowest layer, extending up to about 8 to 15 kilometers above Earth's surface. It contains nearly all the atmospheric water vapor, clouds, and weather systems. Temperature decreases with altitude in this layer. It's also the densest layer and the one most directly affected by human activity. 2. Stratosphere. Located above the troposphere, it extends from approximately 15 kilometers to 50 kilometers in altitude. The temperature increases with altitude here due to the absorption of ultraviolet or UV radiation by the ozone layer, which is concentrated in this region. This layer is crucial for filtering harmful UVB and UVC rays. 3. Mesosphere. Extending from 50 kilometers to about 85 kilometers. The mesosphere is where temperatures again drop with altitude, reaching some of the coldest temperatures in the atmosphere. It is in this layer that meteors usually burn up due to friction with air molecules. 4. Thermosphere. This layer extends from about 85 kilometers up to 600 kilometers or more. The temperature rises sharply with altitude and can reach up to 2500 degrees Celsius or more due to solar activity. However, the air is so thin that it wouldn't feel hot to a human. This is also where auroras occur and where the International Space Station orbits. 5. Exosphere, the outermost layer ranging from around 600 kilometers to 10,000 kilometers above the Earth. Here, atmospheric particles are extremely sparse and gradually escape into space. It transitions into the vacuum of outer space and contains mainly hydrogen and helium. So these are the 5 layers of atmosphere. Functions of the atmosphere. The atmosphere serves several essential functions. Protection from radiation. The ozone layer absorbs and scatters the sun's ultraviolet radiation, protecting life from DNA-damaging UV rays. Temperature regulation. Through the greenhouse effect, certain gases like carbon dioxide and water vapor trap heat in the atmosphere, keeping Earth's surface warm enough to support life. Meteor shielding. Most small meteoroids burn up upon entering the mesosphere, preventing them from reaching the surface, enabling the water cycle. Atmospheric processes allow for evaporation, condensation, and precipitation, which are key to sustaining freshwater supplies and ecosystems. Sound and communication. The atmosphere transmits sound and allows for the propagation of radio waves used in communication. So these are the functions of atmosphere. Now we will see human impact on the atmosphere. Over the past century, human activities, particularly the burning of fossil fuels, deforestation, and industrial emissions, have significantly altered the composition and functioning of the atmosphere. The increase in greenhouse gases such as carbon dioxide, methane, and nitrous oxide has intensified the natural greenhouse effect, leading to global warming and climate change. Moreover, pollutants like sulfur dioxide and nitrogen oxides contribute to acid rain, while particulate matter affects air quality and respiratory health. The use of chlorofluorocarbons, that is CFCs, in the past has led to ozone depletion, although international efforts like the Montreal Protocol have successfully phased out many ozone depleting substances. Now let's see atmospheric research and technology. Modern technology plays a crucial role in monitoring atmospheric conditions. Satellites, weather balloons, and remote sensing instruments provide real-time data on temperature, pressure, humidity, and gas concentrations. This data is vital for climate modeling, weather forecasting, and understanding long-term environmental trends. Let's conclude here. In conclusion, the Earth's atmosphere is an intricate and indispensable system that supports life, shapes weather patterns, and protects us from the harsh environment of space. As degree-level students, understanding its structure, function, and vulnerabilities is essential not only for academic purposes but also for making informed decisions about environmental sustainability. With ongoing research and global cooperation, we can mitigate the adverse effects of human activity and help preserve the atmosphere for future generations. If you found this video informative, make sure to like, subscribe, and share it with fellow students. Drop your questions in the comments below, and we'll be happy to dive deeper into any topic you're curious about. Thanks for watching. Please like, share, and subscribe.